Let's try to work out exercise 5.26, and to do this we will do the same things we've been doing all along, and that is we'll take the determinant 1 minus lambda, negative 1, 2.5, and negative 2 minus lambda. It's going to be a little bit of a challenge because there's decimal in here, but I don't think it'll be too bad for us. So let's come and do a little bit of math. So multiply, that gives us 1 minus lambda, negative 2 minus lambda, and then this is minus plus 2.5 is equal to 0. Okay, so let's multiply all this out. We've got negative 2 plus 2 lambda minus lambda plus lambda squared plus 2.5 equals 0. As I put this together, it looks like, let's just come over here to the next page. Lambda squared plus lambda plus 0.5 equals 0. Okay, well, this is a little bit messy, so you know what, and tell you what, instead of like trying to do it by factoring, which I might can figure it out, let's just do the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I thought you all would appreciate that. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 0.5 all over 2. And that looks like we've got negative 2 plus or minus the square root. That looks like it's a negative 1 all over 2. And so it looks to me like I've got negative 1/2 plus or minus I over 2. Or how about plus or minus 1/2 I. So these are my lambdas. Oh, I should have done lambdas instead of x's. When you sing the song, you sing it with an x, and so it's tempting to always write the same thing. So I believe these are my eigenvalues. I believe my eigenvalues are 1/2 and negative 1/2. So what I'm going to do is I'm going to now try to find my eigenvalues, and so I'll use this matrix right here. And to get my eigenvalue, I'll pick one of these, and let's do lambda equals negative 1/2. Let's do plus 1/2 I, and see how that goes. And that means I'm going to get my my matrix will be A minus lambda, so that's going to be 1 minus negative 1/2 plus 1/2 I, and then in this corner it was negative 1, 2.5, and then in this corner is negative 2 minus negative 1/2 plus 1/2 I. All right, and then we'll have our zeros over here. Okay, and then this is equal, let's just do a little bit of simplifying. So 1/2 plus 1/2, so it looks like we get a 1.5, and then minus 0.5 I, negative 1, 2.5, and this looks like it's also negative 1.5 minus 0.5 I, and 0 and 0. Okay, well, there we go. This looks good to me. And then we need to row reduce this. You could multiply by the 1.5 times 0.5 I, and if we do this, hopefully everything would work out to give us nice round numbers. I'm going to skip that and just go straight to the answer. And as I go to the answer, I know that whatever happens, that bottom row has turned into zeros. So I know that that's my, that is my that is my reduced state. So that means that what I've got for my eigenvectors, so that means 1.5 minus 0.5 I x minus y equals 0. If I move the y to the other side, it means that that is equal to y, and that gives me my eigenvector. So my eigenvector x is going to be in terms, I'm going to use x as my free variable, and so I get 1x, x is equal to x, and y is equal to 1.5 minus 0.5. So there we go. So there's our eigenvector to go with that eigenvalue. All right, and now we're ready to find our matrix. So ideally, if we did everything right, our matrix ends up being 3 parts. I'm going to need more space here. So let's let's just reduce. Let's just erase like almost all of this. So I'll erase everything except for my eigenvalue and my eigenvector. And what I'm going to get is I'll have the first one is made up of my eigenvectors. It's going to be 1, 0, 1.5, and negative 0.5. My next one is made up of my eigenvalues, and so that's negative 1/2. Let's keep with 0.5s. Negative 0.5, 0.5, and then my next one is going to be negative 0.5 and negative 0.5. So I did A plus BI and A minus BI. So there we go. And then finally, this last term, I need to just take the inverse of that. The inverse of that, let's see, we end up getting a negative 0.5, 1, and a negative 1.5, but then our determinant is negative 0.5, so we need to do 1 over negative 0.5. So that makes this a positive 1, makes this a negative 2, and makes this a positive 3. So I think that's the inverse. I could always check. Let's see, row 1, row 1 by column 2, that works. Row 2 by column 1 gives me 1.5 and negative 0.5, and okay, so it looks like that works. So there it is. Now, if this worked, if I did it right, again, after missing that one last time, I'm a little hesitant, but we'll see. We'll try it. Well, I'm just going to multiply it out and see if it works. So let's do row 1 times column 1 gives me negative 0.5 plus 1.5, so it looks like that's a positive 1. Row 1 times column 2 looks like that is a negative 1. Now here I'm going to have a negative 0.5 and a negative 1.5, so that looks like that's a negative 2. And row 2 times column 2 looks like it's a positive 1. So it looks like I've got 1, 0, 1.5, negative 0.5 times that. And let's see, row 1 times column 1 gives me a 1. Row 1 times column 2 gives me a negative 1. Row 2 times column 1. 1.5 plus 1 is 2.5. And now here we've got negative 1.5 minus 0.5. And so that is negative 2, right? Negative 2. Hey, and look, that worked. We got the right answer. Okay, so there we go. That was our first example of finding complex eigenvalues and eigenvectors. And again, notice this middle term. This is a rotation, right? So that's so this looks a lot like our sine and cosine thing. So sine, cosine, cosine, sine. Except instead of being 1/2, it'd be 1 over square root of 2, and that would be that 45-degree rotation. So this is pretty similar to that. Let's come and let's do one more, and then at the end of that one, I want to tell you a little bit about how we think about complex numbers, and hopefully as we think about complex numbers, it will kind of give us a picture about why we should think about this complex eigenvalue being the correct one. But go try 5.28 and then come back and listen to the last video in this section.